In sports science, studies are made to optimize performance in all aspects of sports from fitness to technique. Right? In a game, a player scores 3 points by carrying a ball over the scoring line shown in the diagram as xy. Okay, so let's look at the diagram. Here to here is xy, so this is considered the scoring line. So a player scores 3 points by carrying the ball over the scoring line. So if he can cross the scoring line, he scores 3 points. When a player has scored these 3 points, an extra point is scored if the ball is kicked between two fixed vertical posts C and D. Okay, so this is point C, this is point D, and they are 4 meters apart as shown in the diagram. So if he can kick, okay, just between these two posts, so he gets an extra point. Right, the kick can be taken from any points along the line AB. Okay, so you can see AB, which is perpendicular to the line XY. So anywhere along this line he can take the kick, right, where A is the point at which the player crossed the scoring line AB is perpendicular to XY. The distance of C to D is 4 meters as shown in the diagram, and XC is equals to dy. Where is XC? X to C from here to here is equal to the distance between D to Y. So dy is equidistant as XC, right? The point A is at a distance of A meters from C. So A is here. It is at a distance of A meters from C. Okay, luckily all this information are marked on the diagram itself. And A lies between X and C. Okay, A lies between X and C. The kick is taken from the point K. Okay, this is the point K. So this is where you need to take the kick, where A to K is X meter. So this perpendicular distance to the line XY is X meters. The angle CKD is theta. CKD. Okay, so between the line CK and the line DK is the angle called theta. So these are the information that we are given about this game and this diagram. So now, by expressing theta as a difference of the two angles or otherwise, of course you should not go for otherwise, it's always going to be harder. Show that tangent theta is equals to 4x over x squared plus 4a plus a squared. Okay, that should be pretty easy for you to show, right? So you can see there is a couple of right angle triangles. There is one right angle triangle here, and there is one more right angle triangle, which is ACK. So first let's take this big triangle, tangent of AKD. Tangent means opposite over adjacent. So what would be the opposite of this angle AKD? Opposite is going to be, of course, A plus 4. So it's A plus 4, and the adjacent is simply X. So we're going to just write over X. So that is the tangent of the angle AKD. Now let's go for the second triangle. We want to find AKC, AK to C, this little angle here. Okay, so the opposite for this angle AKC is the length is A, so is A divided by X. So that is tangent AKC. Now what is theta? Theta is the angle AKD minus the angle AKC. So theta is the angle AKD, subtract away the angle AKC, that would give you the theta. So if I were to take the tangent of this angle theta, so tangent theta, if I take tangent to the left side of the expression, I must also take the tangent to the right side of the expression, right? So tangent AKD minus, okay, the angle AKC. So of course this is the compound angle formula. So it's like tangent A minus B. If you open up the brackets, so it's going to become tangent A minus tangent B over 1 plus tangent A tangent B, that formula. Okay, you should remember that from your identity. So tangent AKD minus tangent AKC, we already have tangent AKD, we have already gotten the tangent AKC. So all that we need to do is to take this and just plug it into here and just solve them and simplify until it reduces to this form, and that would give you 3 marks. So tangent AKD is of course A plus 4 over X. From that I'm going to subtract away the tangent AKC, which is simply A over X, and as you can see the numerator can be easily simplified. X and X, both of them have the same denominator. So the numerator is going to be A plus 4 minus A, which is simply going to become 4 over x, okay, as we can see in the next step. So for the denominator, we have got 1 plus tangent AKD is, okay, a plus 4 over x, and tangent AKC, as you might have guessed correctly, so it is a over x. So only in the denominator we have got some multiplication to do. So if you look at the numerator, it is simply a plus 4 minus a over x, since both of them have got a common denominator. So however, for the denominator, we're going to multiply the a plus 4 with the a. Okay, so that's going to become a squared, okay, plus a 4a. And denominator, we have got an x and an x, so that should give you x squared. So let's go to the numerator. Let's cancel the a and the minus a. So that's simply going to leave us with 4 over x. And this is to be divided by 1 plus this whole thing. So I'm going to change the 1 to a x square over x square. So if I do that, so I can combine this as a single fraction. So that's how I get x square over x square, which is a 1. And then this a square plus 4a, which is already there as a numerator for the x square. So when I merge them together, so I end up getting this fraction x square plus a squared plus 4a. Right? So now we have got a division symbol. So we need to convert it into a multiplication. Of course, when you convert a division to a multiplication, the fraction that follows should swap the numerator and denominator. So it's going to become x square over x square plus 4a plus a squared. And here I've got a x here, here I've got a x square. So I could simplify the x with the x square to leave me just an x. So 4 times x is of course going to turn that into a 4x on the numerator. And the denominator is x square plus 4a plus a squared as needed to be shown in that question. Okay, so when you show that, you will get your 3 marks. So that's, there we have it. So it's shown. Now the part 2 says find in terms of a, right, the value of x which maximizes the tangent theta. Okay, so the tangent theta has got to become maximum. Simplifying your answer, find also the corresponding value of the tangent theta. Okay, you need not show that your answer gives the maximum, so you don't have to perform differentiation or second derivative to show or whatever. So at maxima, we know that the derivative, okay, because maximizes tangent theta means tangent theta must be the maximum. So the dx d theta, dx d tangent theta, or sorry, d tangent theta dx, okay, at maximum value of tangent theta should be equal to 0. So we just need to differentiate this function with respect to x. So d tangent theta dx is of course equals to, we're going to use quotient rule on the right hand side. Obviously we will start with the denominator, which is x square plus a squared plus 4a, and let's differentiate the numerator 4x, and that's going to give us a 4 minus, now let's keep the numerator fixed, which is 4x, and let us now differentiate the denominator. Of course the only term with the x is the x squared term. So x square, if I differentiate, it's simply going to become 2x, and of course thereafter we will just copy down the denominator and put a square, right? So that is your v squared. So now let us simplify the numerator. So 4 times x square is 4x square, 4 times a square is 4a squared, 4 times 4a is 16a. I've expanded this, and here I've got a 4x and a 2x. 4 times 2 is a 8x times x is going to become x squared. So as we can see on the numerator, we have got a 4x square minus 8x square. In the next step, we're going to reduce it to minus 4x square. The denominator is still the same, so I didn't touch the denominator. Now let's simplify the numerator. So from 4x square, if I subtract the 8x square, that gave me minus 4x square. So that is my numerator. And then from the numerator, we can see 4 is a common factor in all. So, but I chose to pull out a minus 4 because I wanted the coefficient of x squared to remain positive. So if I pull out a minus 4 out of this, this becomes x squared, and plus 4. Okay, since I have taken out a minus 4 out of it, it's just going to turn into a minus. Oh, sorry, this minus 4a came from this term, okay, 16, minus 16. So then I have rearranged the plus 4a squared into a minus a squared, and so we have factorized the numerator. And when it is equal to 0, it cannot be that the denominator is 0 or the minus 4 cannot be the 0. Only this part of the numerator okay, which is x square minus 4a minus a squared should have been equal to 0. 0 times minus 4 would have made the numerator to a 0, and that means this entire fraction would have become a 0. So for that to happen, x square minus 4a minus a squared must have been equal to 0, and of course x square would have been, if you throw the minus 4a and the minus a squared to the right, it should become 4a plus a squared. And what would be the value of a? So of course you're going to square root the 4a plus a squared. Of course x is a positive distance, so therefore that's the reason why I did not put plus minus. So I've straight away gone to the positive root of 4a plus a squared. So that is the value of x, right? So now we need to take this value of x and let's find out what is the tangent theta. So 4 times the value of x, which I am supposed to substitute with, okay, root of 4a plus a squared. So I'm going to replace all the x here. So there is actually only a couple of x, so 4x and x squared. So I'm going to replace the x's with this value. So I'm going to have, okay, this is actually the value of x squared, right? Okay, this is x squared. So the square root sign of course gets cancelled. So I get a 4a plus a squared plus another 4a plus a squared. So if you simplify that, it is going to be 4 times root of 4a plus a squared. Over here I got a 4a plus a 4a, that's going to give me a 8a, a squared and a squared is going to give me a 2a squared. Once again we can see in the denominator there is a couple of even numbers, so we can pull out, okay, 2 out of it and cancel with the 4 here. So if I cancel with the 4, it's going to become 2 here. So that's why 2. And the 4a and the a squared have got a common factor of a. So I factorize out what is inside the square root as well to write this. And from here, since I have already pulled out 2, so this a squared simply becomes, this 2a squared simply becomes a squared, and 8a would have become a 4a. And since both of the terms also contains a, so I factorize out a, so inside the bracket you have got a 4 plus a. Okay, so if you find it too fast my explanation, you can actually pull out a piece of paper and you can try this slowly again, and this is what it should reduce to. So that should be the value of your tangent theta. Now let's now look at the part 3. The point corresponding to the value of x found in the part 2, which is this, okay, is called the optimal point, okay, the best point. The corresponding value of theta is also known as the optimal angle. Explain why a player may decide not to take the kick from the optimal point. If the player may not be having sufficient muscle power, okay, to take the kick from the optimal point, even though that is the best point, right, the player may not have enough muscle power to take the best kick from that optimal point, and that is one of the reasons that why the player may not decide to take the kick from the optimal point. Now for the part 4, it says show that when angle theta is the optimal angle, tangent of the angle KDA, right, is equals to square root of a over 4 plus a squared, and we are also asked to find the approximate value of the angle KDA when a is much larger than 4, right? So now let's bring back the diagram here, right? Tangent KDA, okay, refers to this triangle here, KDA. So tangent of KDA, that means the tangent of this angle, okay, would be equal to, the opposite for it is x, adjacent would be a plus 4, right? So x over a plus 4, that is the tangent of KDA. From the part 1, we have already shown x is equals to 4a plus a squared square root, right? So sorry, from the part 2, okay, just now we saw this would be the value of the x when theta is optimal. So tangent of KDA, so I can go to the x here and I can replace it with this. So when I replace this, the numerator divided by square root of, a plus 4, and from the numerator of course we can factorize out a. So I'm going to have a times 4 plus a over 4 plus a here, right, with the square root sign for the numerator, okay. Now if you look back at what we need to prove, the numerator is just supposed to have a only, and the denominator here, which it does not have a square root sign, this expression which we need to prove does have a square root sign. So the best thing would be to multiply the numerator and denominator by root of 4 plus a, root of 4 plus a, and when you do that, it's going to become, okay, I split this up, so I get this. So now what I'm going to do is I'm going to multiply, or I can just do this, okay, 4 plus a to the power of half, okay, because square root means power half, and here denominator there's a power 1, so I just subtract a 1, and this is going to give me a minus half. Root a, 4 plus a to the power of minus half, and when you have a negative power, right, so it's going to go to the denominator. So 4 plus a to the power of half, and this half means the square root. So root a over root of 4 plus a. Now I can combine them together and write it as a over 4 plus a whole thing square rooted. Now the next part, they say find the approximate value of the angle KDA when a is much greater than 4. When a is much greater than 4, so what happens to the 4 plus a, right? 4 plus a, of course, if a is much larger, the 4 becomes very insignificant, so it will be almost a. So when it is almost a, so this is going to become a over a, right? So the tangent of KDA is going to become square root of a over a. And how much is a over a is going to be? Of course, a over a is going to be 1, and when you square root of 1, it's going to be equals to 1 as well. So tangent of the angle KDA is going to become almost 1. At what angle or what value of KDA is the tangent of the angle is going to become 1? Of course, 45 degrees. So therefore, KDA should be approaching, okay, almost arctangent 1, which is of course 45 degrees or pi over 4 radians. So find the approximate value of the angle KDA when a is much greater than 4. Of course, KDA should be pi over 4. So that's the answer. Now for the part 5, it says it is given that the length of the scoring line XY is 50 meters. Find the range in which optimal angle lies as the location of A varies between X and C. So let's bring back the diagram once again. It's given that X to Y is 50 meters. Find the range in which the optimal angle lies as the location of A, okay, the position of A varies between A to C. That means you can move it towards X or towards C. So let's now first of all look at XY. XY is XC plus CD, which is 4 meters. And if you recall, we are told that dy is the same length as XC. So I can write it as dy, and then we are told that XC is equal to dy, so I could replace it. So XY is equals to, okay, XC plus dy is the same as XC, so XC plus XC becomes twice of XC plus 4. That's the length of X to Y. So now we are told that the XY is equals to 50 meters. So 2XC plus 4 is of course going to be equal to 15. And if I were to just find out what is the value of XC, right? So I would throw the plus 4 over to the other side. 50 minus 4 is going to become 46. And if 2XC is equal to 46, the length of XC is going to be half of 46. That's going to become 23. So that will be the length of XC. And since, okay, A is between 0 to XC, okay, let me bring back the diagram so that you can see. Okay, A is less than XC, right? Because A is the distance from A to C, right? And you are told that the A can vary anywhere here. Of course, the minimum that it can be is A moves towards C, in which case the A value will become 0. Or if the A moves all the way to X, okay, it can be up to A meters, right? So that's why A can be anywhere between 0 to XC. Of course, A cannot be 0, right? Otherwise, you don't have a triangle at all. So A must be bigger than 0, but A can move all the way to the endpoint C. So it must be less than XC. So your A can be between, okay, 0 right up to 23, because the maximum value of XC is 23. So there we have it. A is between 0 to 23, but 23 is inclusive, 0 is not inclusive. So A must be greater than 0, A must be greater than 0, but can be less than or equals to 23. That's the range in which the optimal angle lies, okay, as the location of A varies between X and C. Oh, sorry, this is not the optimal angle. This is the range of values of A. So from part 2, we actually made the tangent theta in terms of A. Okay, there we have it. So what would be the angle? Okay, so how do I get this? If the value of A, okay, this is 2, okay, 4 plus A over there, so I have got, if my A was a 0, would I end up getting this? No, I would not. Let me see. Oh yes, what I have done is I have rationalized it. That means I have multiplied the numerator as well as the denominator of this with square root of A plus 4A. So if I multiply the numerator with A plus 4A and multiply the denominator with root of A plus 4A, so what would happen is square root of, okay, A times 4 plus A multiplied by itself, the square root sign is going to disappear, and the denominator is going to have this term and a plus 4A. Of course, I can cancel the A plus 4A and the A plus 4A, and that can get cancelled, and that's going to be simplified to this. Okay, so if you want, you can actually try this again, okay, on a piece of paper. Multiply the numerator by this exact thing, okay, root A bracket 4 plus A, and multiply the denominator as well by this, and you can simplify and reduce it and can show that tangent theta would be equal to this. And when A is equal to 0, of course I can substitute A equal to 0, so the denominator is going to become, okay, infinity, right? Denominator is going to become 0, so it's going to be like this, so which is 0, right? So if the denominator is a 0, 2 divided by 0 is going to tend to infinity. At what angle would, okay, tangent of that angle give you infinity? And of course that should be 90 degrees, right? So arctangent of infinity is going to be 90 degrees or pi over 2 radians. Now what about when A becomes 23? So when A is 23, we can also substitute into the tangent theta and express theta in terms of A. And when we simplify that, okay, so tangent theta is equal to this. So I'm just going to replace the A with 23. So I get 2 over root of 23 times 4 plus a 23. And this, when we simplify, it's going to be 2 over 3 times root of 69. And theta would be equals to arctangent of this angle. And arctangent of that angle works out to 0.08 radians. And therefore the range in which the theta should lie, okay, we have already found both the angles, right? So therefore the range of theta should be, it should be greater than 0.08, and it has to be less than pi over 2, because if you remember, A was not inclusive, so pi over 2 is not inclusive, and therefore it should be smaller than pi over 2, and that is the range in which the optimal angle, the value of theta lies.